Around 1.5 years ago, a picture of a supermassive black hole present at the center of galaxy M87 or Messier 87 was taken, which was considered as one of the biggest achievements for the humanity. But taking a picture of something where we can never reach could be so special. Why is this picture can be considered as one of the biggest achievements for we humans? Well, look at these two images. The first image is how the black hole would look like according to Einstein's theory of general relativity. And the second image is, we all know how the black hole actually looks like. Do you see any similarity between these two pictures? In these images, the darkened region we see between the bright circles isn't exactly the black hole. Instead, that just indicates the event horizon of a black hole. The region around a black hole beyond which nothing can escape from the gravity of the black hole, not even light or any other electromagnetic waves, and the image is captured by observing the immense amounts of electromagnetic radiation just outside the event horizon. But the question is, how important is this image? Well, it might actually divide astrophysics into two different eras, one before the black hole image and other after the image. And why is that? There are a couple of reasons for that. As you might have guessed by now, is that this proves Einstein's theory of general relativity to be a sound basis for all astronomical events, and almost everything we assumed to be correct in relativity is in fact correct, and that includes his theory of gravity, the space-time continuum, and the black holes warping space and time. Supermassive black holes are found at the center of every massive galaxy. Our own galaxy has a supermassive black hole of its own called Sagittarius A, and finding this image and thus proving relativity opens doors for us to think about how the galaxies were formed and how the universe came into existence from a gravitational singularity. And after this picture, we are now almost so sure about general theory of relativity that this theory is literally so true and applies in the entire universe. As soon as this theory proved to be totally right, even in the cosmic scale, scientists started getting awards for their works on black holes. As recently in 2020, all the three Nobel laureates of physics, that is Sir Roger Penrose, Reinhard Genzel, and Andrea Ghez, all of them got Nobel for their work on the study of black holes. After several decades, finally, we are now so sure that theory of general relativity is so true, which itself alone can describe the genius of Albert Einstein and possibly the genius of Sir Arthur Eddington too, who also played a decent role in proving theory of general relativity. Now for the curious audience, a black hole is formed when something collapses under its own gravity, and at one moment the density becomes so high and gravity becomes so strong that nothing can escape through it, not even light, and it becomes a black hole. In fact, everything can become a black hole once it's sunk down to its Schwarzschild radius. If you shrink Earth to the size of a peanut, it will turn out into a black hole, and if you shrink the sun to the size of an average city, it will turn out into a black hole. But the question is, how big can black holes get? See the image below. The black hole at the center of Phoenix cluster is 100 billion times the mass of Sun, and its size is depicted in the image. Looks terrifying, isn't that? So that's all for today. Suggest a topic for our next video. Till then, follow our Facebook page Freaky Astrophile, and don't forget to share this video as much as you can. Thanks for watching.